and check homework or grab the homework. But while I'm at that, why don't you guys discuss in your groups which graph belongs to which equation? Go. All right, let's discuss. What'd you guys get? Tristan, give me some insight. Let's go through the process of how you figured it out. So can we separate a couple graphs from another couple graphs, Valencia? The ones with the Y on the right side. So this one and this one, what about those? They're the ones that are going side to side instead of up and down, right, Philip? You see that? So the Y is squared, so it changed the direction of my parabola. Allison? That's what changes, not just the negatives, but the fact that they also have the x's squared, right? Makes them up or down, and they're both negative, so they're both facing down. Good. All right, so now we've kind of categorized them, right, using structure. So which one am I going to put this one with? Right there. Discuss it with your partners. Which one would that one be? You can't figure it out? Okay, in 5, 4, 3, 2, 1. Christina, can you tell me how you figured it out? Which one it is and how you figured it out? So you said that x was a positive 1. Top right, thank you. Let's just go back. That's not right, right? Better? So you said that my horizontal shift is 1, and that's what we did. We went over 1. And then my vertical shift is 3, and so we went over 1, up 1, 2, 3 for our vertex of 1, 3. It's almost easier than the other ones, right? Because the other ones we always had to look at the x over here on the right-hand side, and it was kind of switched, right? So let's just double-check this one. So I'm going to take this color off of these because I'm going to move them anyways. So this one is, this one is my y being squared, so that must be this one. But let's double-check. So my x shift is 3, so I'm going over 1, 2, 3, that works. And my y shift is up 2, so over 1, 2, 3, up 2. So my vertex is at 3, 2. This one I'm going to change my color, which doesn't really make sense, but it needs to. Okay, so which one's which on these two here? But Sarah, where would I put this one? The one on the right or the one on the left? The one on the right. Can you tell me why? So my horizontal shift is -3. So I'm going over 1, 2, 3. And then my horizontal shift, sorry, my vertical shift is +4. So actually my vertex is -3, 4. -1, 2, 3, 1, 2, 3, 4. So we were always talking about the x first, and it was on the right-hand side. Then we talk about the y, and it was on the left. But when we're doing these up here, it's almost like you talk about the one that's in front first, right? The x and then the y. That kind of makes it a little bit easier. Lastly, this one, which goes here. We said that there is no shift on the x and no shift on the y. So my vertex is 0, 0. And of course, we're pointing down and pointing down. All right, so here's my challenge to you. I'm going to give you the Directrix, which is x equals -5. We've normally had Directrix as y equals, correct? Oops, moving my graph. But this time, and I gave you the focus but no I gave you the focus but no vertex. I just want to reiterate that our focus and our Directrix, the vertex goes in between them. Okay? Always in between. So the blue dot's going to go in between. So that being said, let me put my Directrix back this way. So instead of my Directrix being y equals, it's now x equals. I'm not going to take any other questions than that. I just want you guys to think about it and try and give me the vertex, the focus, what P is, and the equation. I'm going to let you, this is going to be a productive struggle for about 5 minutes. I'm not going to take any more questions. I just want you to work it out. So from walking around, that didn't take as long as I thought it was going to take. But some of you are still explaining. Okay. All right, let's start here. So we said that our vertex lies in between the Directrix and the focus, right? So it has to go here. So I'm going to go ahead and plot it, and then I'm going to say, okay, that point is at -1, 2, 3, -3 on my y-axis, and I'm not going anywhere on my, did I say y? -3 on my x-axis, and I'm not going anywhere on my y-axis. We're not having any vertical shifts. All right, so that being said, we know that this is my boundary line, right? I can't cross my boundary line. So that means that this parabola must be going like this. Sorry, it's kind of, I said I can't cross my boundary line, and then I talked about this side. I have to go like this, right? It wouldn't be able to go like this because then I'm crossing that boundary line. That's like the shelf, right, that it's sitting on. All right, well, I need to know how wide it is as well. Well, I know that this distance right here is 2, so that means P is 2. That means all the way across is 4. Doesn't that mean it needs to open 4 as well? 1, 2, 3, 4, because this has to be a square. That's how you can always tell if you've got this distance correct, because going all the way from your focus out to your parabola and then your focus down to your Directrix should make a perfect square. So if I know that that's 4, that means I need to go out 4 as well. So I'm actually going to be writing in my equation at the same time. I always put my squared on this side. I'm also going to tell myself my orientation is going to be, I'm concentrating on the y now, right? So I know this one's going to be y, this one's going to be x. I just found out my LLR, it's 8. We always talk about the distance as being the difference between two things, right? So that's why I've got a minus sign, the difference between two things. So I should finish my graph first, right? So if we go out and out, then my graph would look like that. Hold on. Almost done. So if my vertex is at -3, 0, this is my x translation, and this is my y. So that means I need to go the opposite of 3. That means I need to make this the opposite. And this one I'm not moving at all, so it's just going to be 0. So I really could write it 8 times x plus 3 equals y squared. Now questions. Philip. Yeah. Yes, Valencia. It could be positive 0. We could subtract nothing, or we could add nothing, and we would still have nothing. Good job. And I don't mind if you leave it like this, or Florencia, I don't mind if you leave it like this. It doesn't matter to me. Or if you want to leave it like this. It all means the same thing. All right, thumbs up, thumbs down. How are we doing? Okay, let's try another one. If I do that, so let you guys work with that one for a second. Do you want my little shell thing here? All right, all the way to the equation. I want to see you guys do it. Okay, so you guys basically taught this to yourselves. You are smart. Okay, so if this is my focus, my vertex lies in between my focus, right? I know that this is the bottom of my graph, so I know it's going to have to do something like that. So in order to figure out how wide it's going to be, I need to establish what P is. So this distance right here is 1, so my P is 1. So to go all the way to the focus and out, I have to go 2 and 2. Does it make a box? It sure does. So out to here. So a total of 4. So my equation is going to have a 4 in front of it. Because from my focus to my directrix, that's 2. So then I have to go out 2 this way. Right? Because remember, that is the definition of a parabola, right? The distance from the focus to the directrix should be equidistant from the focus out to the parabola. And that's actually my parabola right there. But I say to myself, this is going in the positive direction. This is going in the negative direction. So it must be -4. Is that obvious enough? Negative? There we go. So all that's left is I need my x and my y. So my y is what's being squared. My x is not. I have a shift of 0 for my horizontal shift and a shift of 0 for my vertical shift. So we're done. We can simplify. Would you rather it be simplified? So my vertex is 0, 0. And you guys would rather me write it -4x equals y squared. Are we good? Do you guys think you need another one? I think we're good. All right, so vertical parabolas and horizontal parabolas. So let's talk about this, and I'm going to put it in your notes. All right, so this is, we're going to call this sideways parabolas. So if we're talking about a vertical parabola, right, that's our normal parent graph of y equals x squared. But we can also talk about our parent graph in the negative direction, which is y equals negative x squared, or how we've learned to write it is negative y minus 0 equals x minus 0 squared. Do you guys want me to put this one like that one too? Or we'll just do that? Is that good? Yeah? Okay. Let's look at this one, the horizontal one. So the horizontal is x equals y squared, and we know it looks like this. So if we want to talk about it in the negative direction, the parent graph would be x equals negative y squared, or negative x minus 0 equals y minus 0 squared. So actually, we're talking about one formula, right, that works for 4 graphs. Because it is the same formula, right? The orientation just changes. We either go up or down, or right or left. And depending on if it's up or down, we're talking about x being squared. And if we're talking about left and right, we're talking about y being squared. So it's important, instead of me writing out 4 different equations up here for you, or 4 different formulas, we look at the structure of just our parent graph and talk about how it changes. Right? Okay. So why don't you guys write that down in your notes. Give you about 2 minutes.